My name is Elizabeth Jackson, and I'm going to be talking to you about server-side programming. So, what is a server? Basically, it's a computer that can run by itself, and it can hold lots of data, like form information, page or browsing history, content, design, and instructions needed for whole websites, shopping history, files for every client, such as a business. Businesses have tons of clients to hold data for. Your most recent email message, your computer information, like an IP address, instructions on how to execute and run programs or website interactions. When a user reaches a website, the website has inner code, like instructions that tell the server how to display a website, what actions to make, and where to store or find certain files if needed. A server can process, compute, and program any action we need it to. Essentially, servers are self-run computers that carry out specific dealings, mainly through a web or browser interface. Code is instructions, whether within the page of a website skeleton, that is what tells the servers how, what, and when to do something. Certain actions will or won't be carried out on conditions an event that occurs on a website or somewhere on the web. A good example of this is when you're on a website, you might have to take a survey, like a personality survey, for example. When you enter in all the details about yourself and whatever things about yourself, it compiles all that information and is sent into the server. The server processes that information and runs it, and it decides whether or not to dispute it or output it as tables, charts, or other diagrams to show you more about your personality and your personality results. So that's a good example, but it's only just one example out of many. And also just simply displaying hello after clicking a certain button. So more about it. So I'm going to have to tell you a little bit of internet background. So the internet essentially is a wire. It's just simply a wire, and it's usually underground. Most people think of the internet as a cloud, floating in the sky, but that's not what it is. It's really just a wire that transmutes information back and forth between itself. And this is a server. And a server, it looks exactly like the block on the ground, part of a computer that sits on a desk without the monitor. So it's just that block part, and it really is just that computer part and can do all that computing and power to power through certain processes and get things done. And so all servers are connected directly to the internet, and there's multiple servers. There's billions of them all across this internet wire. And so we, people like you and me, use computers, desktops, and smartphones, laptops, to connect to the internet. And so these devices actually do not connect directly to the internet. And whenever we try and make, like when we enter an address or try and process a request through a website, that sends information to a server. The server receives that information, tries to process it, and receive information back to display the right contents of a web page to you. And so, yeah, again, this is not directly connected to the internet. And these, what we use, the devices that we use, is known as the client. I don't know why it's called that like that, but it is. And so I'll be calling it the client from now on. So this will show you the indirect connection of the client to the internet. And so it's connected to something called an ISP, or an internet service provider. Um, and so you can't really own an ISP personally. They're usually owned by very large companies like Comcast. It's a cable company, but also sells internet. Also, Verizon, originally a phone company, but also sells its internet to users as well. These companies um, pay a lot of money for ISPs. ISPs are very expensive. There's technicians, electricians, and engineers that all work together and figure out the wiring. There's miles of cabling that has to do with ISPs and in order to make them. So it takes a lot of, I guess, mapping out and work to make ISPs, and the companies pays and works hard to maintain the network services of these ISPs for its hundreds of subscribers, just like you and me. So we need most of us need a subscription to an ISP in order to gain access to the internet. And so let's say, for example, that we're trying to reach a web page and we put in an address. We're sending in a request to get that web page information and that web page content to our screen. So, so we send in that request, pretend that this is information running through the internet, um, asking for that request to a server, and it gets to a server that holds that information for us. The server processes that request, um, and yeah, so once it gets there, the server is able to process that and send it back to the computer and display the website how we want. And so you may be asking, how did that information know which server to go to out of all the billions of servers there are on the internet? That's a good question. So there's something known as an IP address, and every single device, whether it's indirectly connected to the internet or directly connected to the internet, has an address. And there are these numbers right here. And these numbers tell the information exactly where to go, and it knows which device it came from and which one it's going to and how to get there. And so it's exactly how it sounds. It's an address. So I don't know. It's not very fun to really look at these numbers and memorize them and know what kind of information we want. So we actually have names for them that are very well known, such as Facebook, Google, and Wikipedia. So, like, uh, all the addresses that we type into very often have originally complicated addresses, but it's okay because computers can easily transverse the our address names into its original number names because computers are very smart and it's very efficient. So this is a note. Server-side programming is not limited to just programming. People call it many different things. It's also called server-side or client-side scripting, web making, processing, coding, etc. It can be called by many different names. And so I'm going to tell you the opposite side, client-side programming, to help you get a little feel. So the basics, programming and uploading code that can be executed from your own computer. The program code and instructions are stored on your computer where the internet pulls onto your website from. When you make a website with HTML, CSS, and JavaScript, these are the renowned, well-known program languages that are easily known by browsers. These are essential languages that are known, and it's whenever you use these languages, it's most likely client-side programming unless you upload it to a server to keep. So whenever you use any of these languages or codes, it can be uploaded as a website without using a server because they're well known by the browser that you use most of the time. So the difference. Browsers like Google, Mozilla, Firefox, Opera, Internet Explorer all have something magic or similar. They each have HTML, CSS, and JavaScript capabilities built into them so that its code can be executed and run without putting your code on a server. JavaScript is compatible with all modern browsers. Keynote Modern. You simply need just any text editor to client-side program. Windows Notepad, Brackets, Vim, Apple Notes, or any simple text document for that matter. When your CSS and JavaScript are linked to your edited text save as an HTML document, you can type the address in a browser search bar and see your code uploaded as a website. So that's really what client-side programming is. You can upload and execute your code on a website to be fully functional, and the code is all right from your computer where the website instructions are stored. So I'm going to give you a little visual about client-side programming. So we all use browsers, like Google, Mozilla Firefox. There's also Internet Explorer, Opera, many others, but those are just the popular, to name a few. So these browsers have built into them languages that they understand, which is JavaScript, HTML, and CSS. They understand these languages, and it's naturally built into them. So it knows how to execute and run these languages in its code. So let's pretend that we made HTML code right here and also CSS. This actually isn't CSS, but let's pretend it is. So I'll show you how exactly you'd save it so that it can be uploaded onto a website. So we're going to be saving our pretend HTML code. See, save as, we're saving it index.html. Whenever you save a file, this is just a regular text file as .html, your computer will automatically recognize it and make it as an HTML document pretty much and understand that it's HTML language. And so you save it, and now we're going to save our CSS. So saving it as style.css, and again, .css is something that the computer recognizes and processes it as a CSS language or file. And so let's pretend that we're saving this file on home/mywebsite/index.html and style.css for our style document. So yeah, if you have website code, when you type in the address of that code stored into your computer, into the browser, the code that we just saved, like as pretend, the browser can make your website appear right there for you. So let's pretend that we're going to be entering it in. So this address right here is the same, right, as index. So we'll go back, show you that. That's exactly where we saved it on our computer. And we're writing it up as the address. So we're writing this address up, and the browser recognizes these languages and can upload the output of your code as a web page. It's saved on your computer. The browser accesses your code from your computer because you entered in this address, and it brings it up from your computer. And ta-da, your website is displayed, and then it pops up as so. And so, by the way, you don't need to send any request or data across the internet for a server to receive and process to display the website for you. You don't need to send any information to a server whatsoever. It's all right here on your computer, and it pulls up from your computer data, and so no need for a server whatsoever, and that's why it's called client side. So now I'm going to give you a server side visual. So again, we have regular browsers that we use like Google and Mozilla Firefox. And just a reminder that servers themselves are computers. They have instructions and data stored in them that tells them how to read and process certain information. So servers can just store many different languages as well besides JavaScript, because it's just too much for these browsers and your computer to store all those languages and language instructions. So we have servers do the work for us. So here's our internet, our long internet wire, and the servers alongside that. Let's pretend that we're typing in an address like Facebook. So we want to get to facebook.com and have the web page appear on our screen. That's what we want. And so once we type in the address and press enter, we'll be sending a request to a server that has the web page information and can send the web page to our screen. And that's what's going to happen. So we click enter and bam, a request is sent. It's sent to the internet, and it goes through the internet wire and reaches to a specific server with our web page information. So the server receives this request, analyzes the data and interaction given for the request, then processes the proper response to send back to our computer screen. So it properly processes that and sends the data back, and it finally reaches back to our computer. Ta-da! And Facebook appears onto our laptop like magic. So that's how server side works. Server does the information and processing for us for it to display onto our client or device. So yes, browsers can sustain JavaScript and bring your website right to you from your computer. But if every browser knew all coding languages, that would take too much space and computing for a browser. A browser doesn't have a huge capacity to hold all that programming language, and we don't want to put that much data on our computer or browsers either. So we just have servers, servers out here, all these different computers to do that for us. And it knows how to execute, run, and process that code. Yeah, people can program certain code so that servers know what to do when certain things happen on a web page. So we have servers that specifically hold a lot more programming languages, processing, and other computing capabilities to allow them to be in charge and do the work of allowing web pages to respond properly. And that's the main purpose of servers. It does a lot of work for us to make the internet work, essentially. They are very powerful machines, and there's so many of them for many different websites and many different actions and capabilities. So this is the gist of server-side programming. If a website or browser depends on a server to process or send anything to a client, it requires server-side programming. Servers that hold, process, utilize, organize, or file anything for a website's performance, not just from your own computer, would include server-side based regime, allowing the data, execution, loading, request of a page or page interaction to be processed and sent from a server. Web pages can be used by both client-side and server-side usage. JavaScript is the go-to and most renowned client-side language. It's supported by many browsers, as I mentioned earlier, and that's why it's so renowned. The browsers know and understand this language, as well as CSS and HTML. PHP is a server-based language. In order to use the code for your website, you have to upload the code to a server. Because the servers know how to execute and run the language, whereas regular browsers don't guarantee to execute and run PHP straight from your computer. So yeah, you have to upload PHP to a server and have that server whenever like the website with your PHP code is requested, your server then runs that PHP code and displays that code to create the website on a device. Ajax is a language that can be server and client based. An example of this is Google Docs. So I'm going to give you a little demonstration of this Google Docs, I guess, concept. And so this is just a regular Google Docs behind this. And this is an Excel sheet, just like what we can use online. So a user has capability to edit, control, and manipulate the document interface. When a user saves a document, the server saves its updates into its database, and it's stored there. So here's a timeline. This is all going to be user activity from the client, and this is going to be server computing and usage. So let's pretend that we're making an edit on this Excel document, right? So we're making our edits how we need to, and that's user activity that's being done. And then once we decide to save it and we're done with what we need to do for now, we save it, and that data is sent to the server. The server then processes that data and saves it and stores it within its database. And then if we decide to use this document again or edit it on some other day, then the data is sent back so we can get and retrieve that document again, and we start using it, editing it again. And once we save it, then that data is sent back to the server processes it, and once it's processed, it's saved, stored into the server. And then once it's stored, we might decide to edit it again, and it just continues to go. It's all of that. So Ajax pretty much does this. It has a client and server based programming within its language, and so that is a explanation of what exactly Ajax can do, especially with Google Docs, and why it is both client and server-sided programming. So to sum it up, server-side programming can be slower because it has to send a request to a server for it to process and then send back to your computer. And that can take time rather than just sending and receiving the website straight from your computer. It's a lot faster that way with client side programming. So client-side programming can require some more testing and backup checks than server-side programming. And if there's a lot of users or clients using your website, like a business, banks, like many user profiles or account info, your computer isn't going to keep all that user data. Like it's gonna pile up after a while. Your computer can't sustain all that data and information. And that's why businesses need their own servers. A lot of businesses that have, I guess, processes that need users to make a lot of information and give information online and hold their data online requires a lot of servers to hold that information. And so these businesses have these servers to keep the client information safe. And there's also a very limited amount of people who can even get near these servers. It's highly secured. They have security guards, and very few of their even employees can get around these servers because they want to make sure that their client information is safe and that nothing happens to it, and that's very important. And so servers can be a very useful thing when it comes to lots of data storage and huge processing capabilities. And it's a very interesting process. I think it's um, very awesome what servers can do. So, anyways, I hope that this presentation has helped you understand about servers a little bit more and that you understand the basics, and it's helped you out with understanding a little bit more about client and server-based programming. So thank you for watching, and I really appreciate it.